Hello students, welcome to physics class. In this particular video, we are going to be explain about this 14th chapter of II PUC Physics, that is Semiconductor Electronics. And Semiconductor Electronics, around some 10 mark question is asking, and this is a chapter without any numerical problems. Because of that reason, this chapter is important. Those students who find it difficult to get a pass marks, because 10 mark question is asking in this particular chapter. Let us see first what is electronics. This electronics is a branch of science which deals with electron flow over a vacuum or gas or a semiconductor. Okay? Or I can say it is a controlled flow of electrons over a semiconductor. That particular branch is called electronics. You can see in the pictures there will be IC. You can observe this. It is the integrated circuit. There will be a semiconductor chip is there, and the current is passing to this over a semiconductor. Electron is flow through a semiconductor. These particular devices are called semiconductor devices or electronic devices. In this electronic devices, whatever we are using a semiconductor. What is semiconductor, and about these things we will discuss first. What is semiconductor? The solids can be classified into three types, that is metals, insulator and semiconductor. Based on this conductivity or resistivity or band structure, we classify these solids into three types as a metals, semiconductors and insulators. Now based on band theory or band structure, we can understand how it is classified, and about these things we are discuss first. Okay? See, band theory explain about this classification of solids based on its energy band structures. You already know about these atoms in a previous chapter, like that each atoms has a specific structures, like that some number of electrons are revolving in a various orbit as in figure, and these electrons, when it is revolving in a various orbit, it possesses energy, and that energy level diagram already you studied in this particular chapter. If you observe these energy levels of a single or individual atom, these are discrete energy levels, and it is measured in electron volts. Energy is measured in electron volts. And when these atoms are clubbed together, it forms a molecules. Then atoms are come closer, and then energy levels also will be overlaps. And like that we can observe these solids. In case of solids, these atoms are once again very close to each other, and it is tightly packed. As a result, these atoms are very close to each other. These energy levels is become overlaps, and these energy levels, or this discrete energy level, is going to be broadened and forms a energy bands. So that you can observe here 1s, 2s, 2p energy bands are formed. You can observe in pictures when an atom is single, it has a discrete energy levels. As atoms are clubbed together and forms a molecules, as a result these number of energy levels are going to be overlaps. Then when it is forms a solids, the atoms are again closely packed and it forms energy bands. And what is this energy bands? The large number of closely spaced energy levels on solids are called energy band. This large number of closely spaced energy levels are called energy bands. In order to explain this classification of solids, we have a importance of two energy bands. There is a conduction band and valence band. What is that conduction band and valence band? Let us see. The energy band, which includes energy levels of valence electrons, are called valence band. That means the energy bands in which includes the valence electrons energy levels. What is valence electrons? The electrons which is revolving in a outermost orbit. You can observe in picture that those electrons which is revolving in a outermost orbit are called valence electrons, and that valence electrons, whatever possess energy, due to that reason the valence band is formed. And what is the above this valence band, what is the band is present, and that is called conduction band. The energy band above the valence band is called conduction band. Then what is the energy difference between top of this valence band to bottom of this conduction band is called energy gap or forbidden gap. Okay? And whatever this energy difference between the top of valence band to bottom of conduction band, energy gap. Okay? And once again you can see in the pictures that where valence band is there, and it is partially or completely filled by electrons. Few electrons you can observe in a valence band, and above there will be conduction band is there, and it is empty at 0 kelvins. And what is a gap between this particular the valence band and conduction band, and that is called energy gap or forbidden energy gap. And based on this energy gap, we are easily explain this classification of solids as a metals, insulator and semiconductors. Let us see, as the temperature increases, what happens in a solid. So you can observe in a pictures, as temperature is increases above the 0 kelvins, the few electrons in a valence band is jumps to conduction band. As a result, there is a few vacancies created in a valence band. That vacancy which is created in a valence band are virtually positive charge, and they are called holes. And whatever these electrons jump to this conduction band, they are called free electrons. Like that, as temperature increases, this will happens in case of semiconductors. Let us understand this classification of solids based on these band structures. Okay? The metals, semiconductor, insulators are classified based on this band structure. The energy bands in case of conductor, you can observe in pictures. In case of conductor, the valence band and conduction bands are overlaps. Because of that reason, there will be no energy gap between valence band and conduction band. Energy gap is 0. Let's see the energy bands in case of semiconductors. You can see in the pictures, in case of semiconductor, the narrow energy gap is exist between valence band and conduction band. That energy gap, that gap between valence band and conduction band is in order of 0.72 electron volt in case of germanium semi-crystals, is one of the semiconductor, or in another semiconductor silicon, where energy gap is 1.1 electron volt. Like that, a narrow energy gap is exist between this valence band and conduction band. Due to that reason, as the temperature increases, you can observe this, as a temperature increases, electrons are jumping from valence band to conduction band, and is create a vacancy in a valence band is called holes, and what is the electrons present in a conduction band is called electrons. And like that, you can observe in a pictures, there will be a holes is present, there is a vacancy in a lattice side, and that vacancy created because of this transition of electrons from valence band to conduction band can be occupied by neighboring electrons. You can observe in picture, neighboring electron is occupying that holes. As the electrons is moving, and that vacancy also shifted in opposite directions. Like that, in a semiconductor, there is two type of charge carriers, holes and electrons. And we'll have another class of solids, that is a insulators. In case of these non-metals or insulator, this energy band diagram is like this. There will be large energy gap is exist between valence band and conduction band. Due to that reason, it is difficult to transit a electron from valence band to conduction band. Their energy gap is greater than 3 electron volts. Then that type of solids are classified as an insulator, because in these cases it is not sufficient, energy is not sufficient to jump from valence band to conduction band. Due to that reasons, there will be no free electrons in conduction band. It does not conduct the current or electricity. And once again, I can summarize these particular classifications of a solid based on these band diagrams. You can observe these band energy band diagrams. The conduction band and valence bands are overlaps in case of metals. Like that, there will be no energy gap. And in case of semiconductor, the energy gap is less than 3 electron volt, such a way that there will be a narrow gap which exists between this valence band and conduction band. And in case of insulator or non-metals, there will be a wide energy gap between valence band and conduction band, where that energy gap is greater than 3 electron volts. From this picture we can clearly understand the metals in semiconductor and insulator, what is the band structure. And let us see what are the properties of this particular metals, insulator and semiconductors. You can observe here the metals. In case of metals, this energy band diagram shows that conduction band and valence bands are overlaps. Hence, the conduction bands contains sufficient number of free electrons because it is overlaps. Already valence band is overlaps. There will be sufficient number of electrons is available for conductivity, and due to that reason they conduct the electricity or current, and because of enough number of free electrons already exist in a conduction band. And but their resistance increases as a temperature increases, or I can say conductivity decreases as the temperature increases. Example: copper, gold, silver, etc. So that is insulator means, and there will be a forbidden energy gap is large, and hence the electrons in a valence band find difficult to get in a conduction band. You cannot find any electrons in conduction band. Conduction band is empty, and due to that reason they do not conduct the electricity or current, and hence they have a low conductivity or high resistivity. Okay, example: glass, plastic, wood, etc. They have an insulator because of that reasons, or they are non-metals. And in case of semiconductor, there will be a narrow energy gap is exists between conduction band and valence band. That energy gap is order of 0.7 electron volt for germanium or 1.1 electron volt for silicons. That at room temperature there will be some few electrons are present in a conduction band, and due to that reasons they shows a conductivity, but the conductivity lies between conductors and insulators. But as the temperature increases, that resistivity is decreases, okay? Or resistivity decreases with the increase of temperature, or its conductivity is increases with a rise of temperature. So one important difference between conductors and semiconductor. You already know, in a conductor, as the temperature increases, conductivity decreases, but in semiconductor, as the temperature increases, conductivity increases. Example: silicon, germanium, carbon, etc. And you can observe in a picture also, there will be a graph is given. As a temperature increases, the resistance is decreases exponentially. Means resistance is decreases or conductivity increases. But at absolute zero or 0 Kelvin, that semiconductor is a perfect insulator. Semiconductor is behaving like a perfect insulator at 0 Kelvin, but as the temperature increases, this conductivity is increases or resistivity decreases, and it's turned to be a conductor. Classify the semiconductor into two types, as an intrinsic semiconductor means pure semiconductor, and in order to increase this conductivity we will add in some impurity atoms, then it is become impure or eccentric semiconductor. Let us study details about these two types of semiconductor. First we'll see what is an intrinsic semiconductor. You can observe here in a pictures, in a periodic table, there are few elements are present, naturally available elements, and they are called pure semiconductor, and that pure semiconductors are called intrinsic semiconductor. And there are tetravalent atoms. There will be 4 valence electrons in their outermost orbit. You can observe in a pictures, there will be silicons, then in outermost orbit 4 valence electrons are there, and this group of elements is classified as a semiconductors in a periodic tables. And let us see in a semiconductor what is the structures, a pure semiconductor. In a pure semiconductor, for example, you take a silicons, it has a 4 valence electrons, tetravalent electrons atoms we are calling, and that 4 valence electrons is sharing with the neighboring atoms of silicons and forms a 4 covalent bonds. You can observe they forms a 4 covalent bonds with the neighboring atoms, and they are tightly packed, and at a low temperature there will be no free electrons. Because of that reason they behave like insulator at 0 kelvins. But as the temperature increases, as it absorbs some thermal energy, as temperature increases, that some of these electrons is become free, okay? And some of the electrons become free by breaking covalent bonds. As a result, as electrons become free, it create a vacancy, and that vacancy is called holes. It is a positive charge, and whatever electron become free is called negatively charged carriers. This is a free electrons, and these free electrons as well as holes is taken a part in a conductivity. Because of that reason, in case of semiconductor, there will be 2 charged carriers, that is electrons and holes. Okay, you can observe pictures. There will be some number of holes are created because of breaking of covalent bonds, and as a result few electrons are also available in a conduction band and few holes are available in a valence band. But you remember, in an intrinsic semiconductor, number of electrons is always equal to number of holes. ಎಷ್ಟು ಫ್ರೀ electrons ಇರುತ್ತೆ ಅಷ್ಟೇ ನಂಬರ್ಸ್ನ ಹೋಲ್ಸ್ ಕೂಡ ವೇಕೆನ್ಸಿ ಕೂಡ ಕ್ರಿಯೇಟ್ ಆಗುತ್ತೆ. ಹೋಲ್ಸ್ ಆರ್ ದೇರ್, that number of electrons is equal to number of holes. But their conductivity is low. At a room temperature, the conductivity is low. We have to enhance or we have to increase the conductivity. By raising temperature, of course, its conductivity may increase, but it is not practically not possible. And because of that reason, we are adding some impurity atoms. We are adding some impurity atom to the semiconductors, and that type of semiconductor is called eccentric semiconductor. What is eccentric semiconductor? A semiconductor doped with a suitable impurity to increase its conductivity, and such a semiconductors are called eccentric semiconductor. Okay? Such a semiconductors are called eccentric semiconductor, and depending upon what type of impurity atom we are going to be added to the pure semiconductor, we have a 2 types. Okay? Really, ಎರಡು type ಇದೆ. One P type of semiconductor or N type of semiconductor. For that, what is a doping? The process of adding impurity atoms to the pure semiconductor is called doping. The process of adding impurity atoms to the pure semiconductor, the small quantity of impurity atom is going to be added, such as that these physical or chemical properties of these pure semiconductors should not alter. In that ratios, a few impurity atom is going to be added. That process is called doping, and atom which is added is called dopant. Okay? The impurity atom which is added is called dopant, and there will be 2 type of dopants we are using for a silicon or germanium, and it may be a pentavalence, means 5 valence electrons atoms going to be added, and or for example arsenic, antimony, phosphorus, etc. they have a 5 valence electron. This is one type of impurity atoms usually going to be added to the semiconductor. Or trivalent impurity atoms like 3 valence electrons atoms also can be added, and for example indium, boron, aluminum, etc. that also can be added, and such a way that we can get a impure eccentric semiconductor. Depending upon which type of impurity atom which is added, we have 2 types, N type and P type. See, there is a 2 type of eccentric semiconductor. There is a N type of semiconductor and P type of semiconductor in details. The N type of semiconductor, okay, when eccentric semiconductor is doped with a pentavalent impurity atoms like arsenic or bismuth, etc., and which the negatively charged carriers like free electrons works as a charge carriers, and is called N type of semiconductor. Their electrons are extra electrons are present. Because of that reason, it is totally negatively charged, and due to that reason, it is named as a N type of semiconductor. There, whatever is in picture, you can observe arsenic as doped with the silicons. There will be some of the silicon atom is replaced by arsenic, and but arsenic has a 5 valence electrons. It required only 4 valence to form a 4 covalent bonds. Then one additional electrons is attached in this particular parent elements. Whenever you apply a potential difference, that is available for conductivity, and like that there will be extra electrons is available, and that impurity atom is giving one extra electron for conductivity, and due to that reason that atom is called donor atom. Impurity atoms are called donor atoms. And if you observe these pictures, you can observe that there will be a 3 electrons, there is additional charge carrier is available in a conduction band. Total band, if you observe here, conduction band has more electrons than holes in a valence band. Like that, electrons is more number than holes. Ne is greater than NH, and electrons are more in number. They are called majority charge carrier, and holes are less in number, and with that reason they are called minority charge carrier. This is a p type of semiconductor. Next you see, this is a n type of semiconductor. Next you see p type of semiconductor. In case of p type of semiconductor, eccentric semiconductor is grouped with a trivalent impurity atoms like aluminum, boron, etc. There will be 3 valence electrons are there in these atoms, and like that it is replaced, few atoms is replaced by trivalent impurity atoms, and such a way that one extra hole is creating, and that hole is works as a charge carriers. In case of p type of semiconductor, that hole is positive charge. Due to that reason is called positive type or p type of semiconductor. Every trivalent impurity atoms is donating one extra, because that bond is incomplete due to one shortage of electrons. That particular place is always accepting one electron from neighboring atoms, and due to that reason that impurity atom is called acceptor atom. That impurity atoms which is present in p type of semiconductors called acceptor atoms. If you totally observe this structure is like this, there will be one vacancies there in every one impurity atoms, and already as a temperature increases, few vacancies created in valence band, few electrons in conduction band. If you count total number of valence electrons as well as these holes, electrons are minority charge carrier, less number, holes are more number, or number of holes is greater than number of electrons. As a result, we can say holes are majority charge carriers and electrons are minority charge carrier in case of p type of semiconductor. So that we can totally summarize like this. Usually in examination they are asking distinguish or write a difference between p type and n type of semiconductor. The p type or n type of semiconductors can easily differentiate by adding some impurity atoms. See here, in n type of semiconductor is obtained by adding pentavalent impurity atom. P type of semiconductor is obtained by adding trivalent impurity atom to the semiconductors. Like that, in n type, the whatever impurity atom is added is called donor atom, is donating one extra electron to the conductivity. Or in p type, what is the impurity atom is added is called acceptor atom, because it is giving one extra force to the semiconductor. And in n type, electrons are majority charge carriers. In case of p type, holes are majority charge carrier. Or in case of n type, electrons are majority, means holes are minority charge carrier, and in case of p type, electrons are minority carriers. They are the differences between n type of semiconductors and p type of semiconductors.